Let's talk a little bit about slope for a minute. I think most of you have a basic understanding of slope. It talks about the rise and run of a line. We don't always talk about slope using the same terminology though, or the same definition. And so we want to make sure that we understand all of the different ways that we could describe slope. I just said that we talk about slope in terms of rise over run, which is how much up and down compared to how much left and right we've got going on in a line. We give slope the variable m. Sometimes we'll talk about it in terms of the change in y over the change in x. I know this looks like a triangle, but really it's the Greek symbol delta, which means change. And sometimes we'll just use the formula for slope, which is y2 minus y1 over x2 minus x1. It's important that we understand that all of these things mean exactly the same thing. They're all talking about slope. So rise over run is the exact same thing as how much up and down it moves compared to how much left and right it moves, which is the same thing as slope, which is the same thing as delta y over delta x, which is the same thing as the formula y2 minus y1 equals x2 minus x1. So let's go ahead and take a look at a few examples as to how to find slope if we're given two different points. We can find the slope of the line that connects those 2 points. So let's say that we have the points, we'll have our point 1 be a negative 2, 5. And our point 2 could be maybe at 1, negative 4. Now remember the formula that we were working with was y2 minus y1 over x2 minus x1. Now these small little 2's and 1's are written in subscript, which means they're smaller and a little bit lower than the other information on the line, and they're strictly there as identifiers. We know that when we have an xy pair, the first value is x, the second value is y, but if we start getting a whole bunch of xy pairs, they're called coordinate pairs, if we get too many of those going on, it's a little bit difficult to decide which x value we were talking about compared to which y value. So we use these identifiers. Point 1, the xy pair, would be x1, y1, meaning that they are point 1, x and y. So our point 2 xy pair would be x2, y2. So we can take these identifiers and it helps us figure out exactly what information we're working with. So if I wanted to plug in y2 minus y1, I could take my y2 value, which is a negative 4, and subtract from that my y1 value, which is 5, and put that over my x2 minus x1 values. My x2 value is 1, and I would subtract from that my x1 value, which is a negative 2. So we have a negative 4 minus 5, which is negative 9, over 1 minus a negative 2. So let's just take a little side note right here. And remember that 1 minus a negative 2 means a negative times a negative, which is a positive. So 1 plus 2 is really 3. So right here we have 1 plus 2, which is 3. We can reduce this down 3 actually goes into negative 9 a negative 3 times. So our slope is really a negative 3. And remember, whenever we're working with a whole number, we could write that whole number over 1 and it means the same thing. So this slope is really saying that we would travel down 3 and to the right 1 unit for a slope of negative 3. Let's look at another example with me talking maybe a little bit less. Sometimes I think that's helpful. So we have our first point, which is 4, 0. And our second point, which is negative 1, negative 2. So using our formula, y2 minus y1 over x2 minus x1. Point 1 gives me x1, y1. Point 2 gives me x2, y2. So y2 minus y1 over x2 minus x1. Negative 2 minus 0 is a negative 2. Negative 1 minus 4 is a negative 5. Negative divided by a negative is a positive. So our slope in this case is 2/5. All right, let's look at a couple more examples that are a little bit unique, right? They kind of throw us off a little bit when we run into them. So let's start again with our points. This time we'll have the first point be negative 3, 2, and the second point, let's switch colors here. Our second point could be a negative 3, 5. Now notice what's happening here is that we have a negative 3 for both x values. So let's just kind of see what that's going to look like. We have our x1, y1 here, our x2, y2 here. So we'll start with our formula, y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So 5 minus 2 is 3. And negative 3, remember this would become a plus. Negative times a negative is a positive. So negative 3 plus 3 is 0. So our slope is 3 over 0. Now we have a problem here. We cannot have 0 as a denominator because think of what a denominator means. The denominator tells us how many parts we're going to break something into to be a whole. We cannot break something into 0 parts. So this actually cannot exist. So what we say then is that the slope in this case is undefined, because you cannot define a denominator as 0. So let's see what this would look like if we were to just kind of really quickly sketch this out. Okay, so our first point right here, when x is negative 3, y is 2. And our second point, when x is a negative 3, y is 5. Sorry, I didn't look at my points before I drew my picture here. When x is a negative 3, y is 5. And so our line is actually a vertical line. So if we think about what slope is really saying, rise over run, we have all the rise in the world. We're going up and down as much as we want to go, but we're not going anywhere left to right. So it makes perfect sense for an undefined slope to be a vertical line because we're going up however much we want, but we're not going left or right at all. Okay, so that's one of the unique examples. Ooh, let's put him over here and kind of compare it to the other unique example. As you can probably imagine, since we just did a vertical line, now we're going to talk about a horizontal line. So, in this scenario, let's say that we have the points 4, 0 and negative 2, 0. Notice our y values this time are the same. So we have our x1, y1 and our x2, y2. Plug them into our formula. y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. 0 minus 0 is 0. Negative 2 minus 4 is a negative 6. So our slope in this case is 0 over negative 6. Well, when your numerator is 0, you have 0 parts, so it doesn't matter how many parts it takes to make a whole. Your slope is just going to be 0. So remember again what this means. We're talking about rise over run. So this one's saying that we have no rise and all run. So we're going to have a horizontal line, right? So let's go ahead and sketch this one out. Okay, so our first point when x is 4, y is 0. And our second point when x is negative 2, y is 0. So you can see that we have a horizontal line right here that is all run and no rise. So that's our second kind of